Okay, we are going to talk today about solving both exponential and logarithmic equations. First, we're going to do exponential equations, and there's two kinds. There's kinds where you can get a common base on both sides, and there's kinds where you can't. We're going to start with the ones where you can. So this is solving an exponential equation with a common base. When you're doing this, it means that you could get both sides to have a common base. Would you agree? I can write 16 as a power of 2, right? 2 to the 4th. And I can write 8 as a power of 2, 2 to the 3rd. Would you agree? That's possible. So it would look like this. 2 to the 4th to the 3x equals 2 to the 3rd. And using my laws of exponents here, I would multiply the 4 times the 3x, and this would give me 2 to the 12x power equals 2 to the 3rd power. Now, once I have my equation written, so I have the same base on both sides, it means that my exponents must be equal. So I can write the equation 12x equals 3. Divide both sides by 12, and I get x equals 1/4. All right, one more of those. Would you agree? If we go over here, I have a 27 and 81. Those are both powers of 3, right? So 27 is 3 to the 3rd. 81 is 3 to the 4th power. Multiply my exponents right here, and I get 3 to the 9x power equals 3 to the 4th power. Now, since I have the same base on both sides, these exponents must be equal. So I have 9x equals 4. Divide both sides by 9, and I get x equals 4/9. Now, you're really lucky if you have the same base on both sides, but most of the time that is not going to occur. All right? And as a result, you're not going to get a nice, pretty fraction. See me calling fractions nice and pretty? All right? So you're not going to get a nice, pretty fraction. You're going to get some awful decimal, but that's what we got. Would you agree? I have a 15 and a 285. Can you fathom any way that I can get both of these sides to have the same base? No, this is not going to work well. So we're going to do a different strategy. Let's write our strategy up here. And that is to take the log on both sides. And we're going to let our calculator do the work for us. So here's what we've got. Log, and remember, if you don't see a base on your log, it's base 10. So log of 15 to the 3x power equals log 285, right? All I did was take the log of both sides. Now, remember those laws of logarithms that we just learned? We're going to take that 3x and we're going to move it to the front. Because the whole point, we need to get that x out of the exponent. So now I have 3x log 15 equals log 285. Now, I want x by itself, because if I can get x by itself, I have an answer, right? So let's get rid of everything else. Divide by 3 log 15 on both sides. And what I have is x equals log 285 divided by 3 log 15. At this point, you've got to go to your calculator, and you need to be careful putting this in there. So log 285, right there, divided by, get yourself some parentheses, because you need to do 3 times. 3 times log 15, close parentheses. All we've done is put this whole big disgusting thing in our calculator. And we get x equals 0.6958. There we go. Let's do one more of these. Okay? Can't get the same base on both sides. Can't do it. Alright? Take the log of both sides. Log 5 to the 2x power equals log 130. You're going to use law 3 to move your exponent to the front. So we're going to have 2x log 5 equals log 130. We want x by itself, so divide everything by 2 log 5. And now you actually have x. X equals log 130 divided by 2 log 5. So again, we're going to put this lovely into our calculator. I have log 130 divided by 2 times log 5. Close, close. And I get x equals 1.5122. Alright, so we took the log of both sides. We are not getting beautiful answers. And this is the point. These don't necessarily come with beautiful answers. They come with awful decimals, but we can find the awful decimals by taking the log of both sides. Okay, next kind of problem that we're going to have is a logarithmic equation. Let me put the definition of the logarithm back up here for you because that's what we're going to use. Y equals log base b of x means the same thing as x equals b to the y power. And the reason I'm going to write that there for you is because that is what we're going to use to do this. So this right here is like my x. This right here is my y. And if you look at this, I have no base. So my base must equal 10. Alright, and I'm going to put it in this format. So once I do that, I have 4x minus 3 equals 10 to the 2 power. This is x equals b to the y power. Now I have an equation I can totally solve. So this is 4x minus 3 equals 100. Add 3 to both sides and I get 4x equals 103. Divide both sides by 4 and I get x equals 103 over 4. A lovely, lovely fraction. Alright, let's do this again. Label everything. So this right here is your x. Your b happens to equal 10. This right here is your y. And when we rewrite it, we're going to have 3 minus 2x equals 10 to the negative 1 power. And 10 to the negative 1 power is 1/10. So you can do this either as a fraction or as a decimal. So 3 minus 2x, I'm going to do it as a decimal, 0.1. Subtract 3 on both sides, and I have negative 2x equals 0.1 minus 3, negative 2.9. Divide both sides by negative 2, and I have x equals 1.45. One more kind of equation that we're going to do. And it's a logarithmic equation, but we do have an extra step or two to do. Okay, if you take a look at this, I have 2 logs. The first thing we're going to do is use the law of logarithms. And so these separate logs give me the log of x times x minus 3. This is law 1 equals 1. Now that I've got one logarithm one logarithm. This is my x, this is my y, my b equals 10, and I'm going to have x times x minus 3 equals 10 to the 1 power. Go ahead and distribute that. So I have x squared minus 3x. I'm actually going to subtract my 10 and move it over there, equals 0. And the reason why is because I can actually factor this. This is x minus 5, x plus 2 equals 0. And I now get x equals 5 or x equals negative 2. We would want to go ahead and check these. You can just go ahead and plug them back in to go ahead and check them. And that's the end of what we're doing today.